Hello everyone, for this video we'll be talking about different inferential tests, the basic ones that you can use in order to test for differences. So in this video we'll talk about how we understand and imagine relationships between variables in statistics, and then we'll try to look into what are the things that we consider in order for us to choose a specific inferential statistics to test a specific relationship, whether it exists or not. And then we'll talk about different tests tests for difference between two groups, and then tests for difference among three or more groups. And then we'll talk about tests for difference when we have repeated measures. So when we talk about relationships between and among variables in statistics, we actually are looking for covariations between the variables. Like, for example, is there a pattern that links a variable A with variable B? Do they behave in a fashion that would make us think that they they have a similar pattern? That they could probably be moving the same way or moving in a specific direction. For instance, when one value increases, does the other value of another variable decrease? And we can imagine this in different types of variables. Like, for example, when we think of, let's say, family belongingness, and then religiosity, and you measure them as continuous variables in a scale, you would see how, across the different respondents, is there a pattern in the way the values behave? And will the increase in family belongingness be somewhat related to, or will it covariate with the increase with religiosity? So basically, that is what we're looking for in testing relationships. We want to see if there is a pattern between the movements from one of the variable from one person to another in the given sample. And we can also imagine covariation or relationships when there is a categorical variable. Like, for example, do we see higher values of family belongingness or higher values of religiosity among females or among males? The only difference is that when your other variable, or when your first variable is a categorical variable and the other variable is a continuous variable, usually we describe that relationship in the context of difference. Difference meaning, is there a specific difference in the way the continuous variable behaves when you group the sample based on a certain level of the category or another level of the category? So in this case, the question would be, would there be a significant difference in the context of, in the way the values behave within family belongingness when you group the students, or when you group the sample according to sex at birth? So females versus males. Now, there is a plethora of statistical analysis that we can make use in order to make an inference, or make an inference in relation to the patterns of relationships that you have between and among variables, kaya nga inferential statistics. And there are certain questions that we need to ask and answer in order for us to be able to say na, I'm going to use a t-test or an ANOVA or a Spearman or a Mann Whitney U, or I'm going to use a regression or a Pearson, etc. So the first question we can ask is, how many dependent variable or outcome variables do we have in this specific relationship that we're testing? Now, at least in our case, in our practice, we will be dealing with relationships that only have one dependent or one outcome variable. Because the ones with more than one outcome variable, mas mataas yung level of statistics na gagamitin natin. Okay, but that's the first question. If there's only one outcome variable in that relational model that we want to test, then there's a specific set of statistics that you can use, and then if it's more than one, then there's a specific set of tests that you can use. Like, for example, a singular outcome, you can use an ANOVA. more than two outcomes, you can use a MANOVA. No? But we will not be discussing MANOVA in this class. We'll just be discussing the ANOVA. And then next is how are the dependent variable or outcome variables measured? So again, in a relationship, you have at least two variables, and then one of those variables is an outcome variable. And of course, the first variable is as an independent variable or a predictor. And then usually we have to ask, very important, is what is the nature or what is the level of measurement of the outcome variable. So basically there are two answers here, no? Is it a categorical variable or is it a continuous variable? So that's the question. No? So if it's a continuous variable, then you have a plethora of statistics that is already like that's a set of statistics that may be your options based on your answer for the next question. So it can be ANOVA, t-test, Pearson R, Spearman-Rowe, etc. And then you have when it's a categorical outcome, then the options that you have will be littler. No, you can just go for a chi-square or a logistic regression. But those tests will not be covering that in our class. No. Kasi most of the time in social statistics, we usually our outcome variables are usually in the form of a continuous variables, just like the variables that you are working on in your sample values. Next question is, how many independent variables or predictor variables do you have in your study? Now, when you have more than one independent variables, when it's more complex, ibig sabihin you have more than two variables that you're looking at, one is an outcome, and then you have more than one independent variables, then that's a little bit more of a higher level of statistics that you will need. You will need a multivariate test, no? But if it's only just one independent variable vis-a-vis one dependent variable, then that's bivariate. So that's one classification of an inferential statistics. If you are only dealing with two variables at a time, then that's bivariate. But if in that test you can deal with more than two variables at a time, then that's a multivariate. Now, ideally, when you are already kind of intermediate, when you're doing your statistics, the more ideal is to go towards multivariate tests because it's just one test and you can already make multiple inferences out of the behavior, out of the patterns of the values in your variables, no, compared to a bivariate. But bivariate is a little bit more fundamental, and that's the first thing that you have to learn first, and that's what going to be most of our inferential statistics will be in this class. And the next, also very important, is the nature of the independent variable. So, like I said, we'll be working mostly with continuous outcome variables. But for independent variables, most of the time we'll be working with different types of independent variables. Some independent variables will be categorical with two categories, so dichotomous, or three or more categories, so that's multivariate, no? Multinomial. So iba. And then what if your independent variable is also continuous variable? So there's a specific test that you will run based on the nature of the independent variable and based on the nature of the dependent variable. So next question is, if the independent variable is categorical, no? So again, diba, it can be continuous or categorical. If it's categorical, are there only two groups? Because when it's only two groups, then there is a specific set of statistics that you can use for two groups independent variable, and then there's also a specific set of statistics that you will use for three or more categories. And then next is, if the IV predictor is categorical, are they matched or same, or different participants used in each category? Because for example, meron tayong tinatawag nga where there's what we call a repeated measures. When you say repeated measures, you measure the same variable in two different points in time, no, or at least two different points or two or more points in time. Like for example, if I'm going to measure, let's say, depression prior to the pandemic, and then I go back to the same participants and then measure their depression during the quarantine, and then I measure their depression after the quarantine, then that's called repeated measures, no? So the categories are not really categorizing people, but they are actually categories of the time to which they are measured, but we are talking about the same participants. And then there, of course, there are there are those that are not matched or not same. Like for example, we are measuring depression scores in a single period in time, but we are differentiating the group of males and females, or the group of first year, second year, third year, fourth year. That's a different, because the first one that I'm talking about, for example, we're going to differentiate the measures of depression in pre, during, and post lockdown, or versus differentiating depression among males and females, or between males and females. The first one is what we call a within group, no, a within group analysis, no, meaning this is your participant, no, so you're going to be measuring in pre-lockdown, during lockdown, after lockdown, right? But you also have the other one, which is a between group, no, meaning, for example, you have your depression scale, and then you have males versus females, so two different groups. But the other one is the same group but different measures. Okay, so, and then finally, does the data meet assumptions for parametric test? So we taught you earlier whether it's is it normally distributed? Is there issues with skewness or kurtosis? Because after you answer all of these questions, and you will usually be ending up with two options. The first option is a parametric option, and the second option is a non-parametric option. So for example, let's just do this, no? For example, if my dependent outcome variables, I only have one. So let's say my before I continue, let me just clean my board first. Okay, so allow me to continue. All right, so first, let's say I'm going to measure the relationship between, let's say, depression, no? Depression, and then versus, let's say, depression scores, and then we're going to see if it's related to, let's say, academic performance. Academic performance is measured via grades. Grades as in numerical, like 80, 90, not the 1, 3, 4 in LaSalle, but like the 80, 90. Okay, so how many dependent variables? It's only one dependent variable. All right, and then how are the dependent variables measured, or how is the dependent variable measured? So as I said, it's 81, 90, 95. So it's equidistant, no? And so it is a continuous variable. Next, how many IV or predictor variables? So as I said, in this hypothesis, we only have one, which is depression score. So that's one. And then how are the IV predictor variables measured? So depression, since it's a score, it's measured as a scale. So it's also continuous. Okay? So we will no longer answer IV predictor is categorical because we already established it's continuous, and this one we will also not answer because the answer here is continuous. And then next question is, do we meet assumptions for parametric tests? Now, if your independent variable and dependent variable are only just both one, no, tig-isa lang sila, and they're both continuous, you're left with two options to test for the relationship. The first option is a parametric one, and the parametric one, we will learn this next week, no, is the Pearson-R correlation. And then, if it's a non-parametric, ibig sabihin, hindi niya na-meet yung assumptions of normality, then we use Spearman rho. Okay? So, that is what we will do. Okay, so that's how you kind of use this guideline in order for you to be able to find out which tests you're going to use. So, now let's go for the tests for difference. Now, for the tests for difference, usually, our independent variable is categorical. Okay? And now, basically the issue now here is how many categories? Do you have 2 categories or do you have 3 or more categories? So let's start with when you have 2 categories and your dependent variable is continuous, what you would do. So what is an example of a research question or hypothesis that would usually warrant this type, no? Yung 2 categories. For example, what is the relationship between gender, which is measured as male versus female, and life satisfaction? Life satisfaction, which is a continuous variable. Or if we articulate that as a hypothesis, like what you did in your previous homework, is there a significant difference in life satisfaction when grouped according to gender? And the gender has 2 groups. So, when the independent variable is dichotomous, meaning there are 2 variables, and the dependent variable is continuous, and we have met the parametric requirements, meaning normally distributed yung data, usually we use an independent test. Sorry, an addition, no, in terms of identifying whether there's normal distribution, some more conservative researchers, usually they can, even if the data is normally distributed, usually they still go for a non-parametric because the sampling was not collected via random sampling. No? So, hindi nag-random sampling. So, usually for them, hindi na talaga yun non-parametric. But there are more progressive or more liberal statisticians who say na as long as you meet the assumptions of normality, whatever your sampling technique was, okay na tayo. No? So, what are the different values that you need to check in your statistical output when you do your t-test? No? So, you have to check first, again, no, if the p-value is less than 0.05. So, if the value is less than 0.05, as we have discussed in our previous discussion, that's the time we reject the null hypothesis. So that's the first thing that you check. So mamaya, I will demonstrate to you how to do it via JAMOV. So that you will no longer be using this very cumbersome formula. No? So I will not teach you about the formula. I will teach you in terms of how to kind of generate a JAMOV test using a t-test, and then how do you interpret the tables in the t-test. So the first value that you need to check is the p-value. If the p-value is 0.05, then you have to reject the null hypothesis. And then you have to report the t-statistic. No? And then you have to also indicate the mean and standard deviation per group. So there is an overall mean and standard deviation of life satisfaction as a whole, but you also have to see the mean and standard deviation of males versus females to see. So may significant difference. And then the next question is, who is significantly higher? Is it the group of males or is it the group of females? And the one that's going to give you an answer to that is to check the mean and SD of each group, which is again also, there is a command for this in JAMOV. And then also you have to look at Cohen's D. No, so you have to click on Cohen's D and then look at the value of Cohen's D in order for you to identify the effect size. Now, in our department, or usually we don't report the Cohen's D anymore, but I'm teaching you this because maybe you will be publishing in the future and some of the editors would need to see Cohen's D. Now, there are 3 ways you can interpret Cohen's D as an effect of an independent t-test. So, if it's 0.2, it's small effect. Medium is 0.5, so that's medium effect, and then 0.8, that's large effect. Now, if your IV is dichotomous, like male versus female, and then your dependent variable is continuous, LSS, but you did not meet, no, you did not meet the requirements of a parametric test, hindi normal yung distribution ng data, or you only collected via convenience sampling, then you have to do a non-parametric you have to do a non-parametric. The non-parametric version of independent t-test is Mann Whitney U. No? So, pag Mann Whitney U, what are the values that you have to check? So, just like any type of hypothesis, you have to look at the p-value. So, if the p-value is less than 0.05, then you have to reject the null hypothesis. And then you have to report the U statistic you have to report the U statistic. So, ang generate ng Mann Whitney U is a U statistic, no? And then it also has a p-value for you to say whether or not you're going to reject or not reject the hypothesis, the null hypothesis. And then you also have to arrange for or report the mean and SD per group. So just in case there is a higher value for the just in case there's a significant difference, you can kind of find insights whether who is higher, is it the males or the females. Now, what if your independent variable has 3 or more categories? So let's give an example. What is the relationship between income bracket being low, middle, high? So that's 3 categories. And life satisfaction being a continuous variable. Yeah. So how do we articulate that? How do you articulate that as a hypothesis, no? Or a question? No? Is there a significant difference in the life satisfaction when grouped according to income bracket? So in this case, no, your independent variable is multinomial, or you have 3 or more variables. So examples for that would be yun nga, income bracket, probably another would be yung first year, second year, third year, fourth year. By the way, no, there again is an argument, no. For example, some would say that when you use an ordinal variable, like for example, first year, second year, third year, fourth year, that is an ordinal variable. You can use a non-parametric, version of Pearson R for that. So you can use Spearman Rho, no. But sometimes there are also conservative researchers who would say na even if it is categorical, even if it's an ordinal variable like first year, second year, third year, fourth year, you have to treat it as a categorical variable. So I'm just saying that because you have to be really prepared, no, because some statisticians will have the decision, or some researchers will have this type of decision, some researchers will have that other type of decision. So in this case, but it's very clear, no, low, medium, high, it's better to really treat it as a categorical variable, even if there is an obvious rank, no. So but the DB is continuous, so life satisfaction scale is continuous. So what do we use? If it is a parametric test, ibig sabihin you can assume that there is normality, no. Then you can use what we call a one-way analysis of variance, or ANOVA, no. So what are the values that you need to check upon generating your ANOVA? So first, of course, is the p-value. So if it's less than 0.05, then you can reject the hypothesis. You have to report the F statistic, no. So again, t-test ang nilalabas niya, t statistic. Mann Whitney U ang nilalabas niya, U statistic. Ang one-way analysis of variance ang nilalabas niya, F statistic. And then it would be nice that you will also report for the mean and SD per group, and then you also do a post hoc analysis, no. Examples of when you say post hoc analysis, for example, there is a significant difference when in the life satisfaction when group according to income bracket low, medium, high. There's a next question is, okay, so which among these groups have an actual difference? Is it low versus high, low versus medium, or medium versus high, or all of them. So in order for you to answer that second follow-up question, you have to do what we call a post-hoc analysis. And you can either do Tukey or Bonferroni. There are options that you can find in Jamovi. I will teach you that later. And then we have when your IV is multinomial, so 3 plus variables, so low, medium, high income, for example, and then continuous life satisfaction scores, but you did not meet the parametric requirements. It's that not the distribution is not normal. Then what you will use is a Krukall Wallis test, no? Pag hindi na meet yung normality. So, what are the values that you need to check? So, if p-value is less than 0.05, then as usual, you have to reject the null hypothesis and honor that there is a significant relationship across the income brackets in terms of life satisfaction. And then, the statistics that you will report is the x squared. And then you have to identify the mean and standard deviation per group. And then you will also do a post-hoc analysis just in case you need to do a pairwise comparison, no? On the, again, low versus medium, medium versus high, low versus high, and you know, or if all of them has a pairwise Now, remember, you will only do a post-hoc analysis when the p-value is less than 0.05. If it's not significant, then there's no point of doing a post-hoc analysis. The next type of test for difference is again, so itong naunang dalawa, these are between groups, no? Between groups difference, meaning we're looking at the value of a given outcome variable based on when grouped according to different groups, no, different categories. But here in this question, is there significant difference in the life satisfaction pre and post lockdown? So we're not going to differentiate, you know, the life satisfaction across groups, no, within the larger sample, but it is within the same group, no. It's just that we might need there is a repeated measure, no? Ano yung repeated measure? We're measuring the same life satisfaction, but the first measurement was measured pre-lockdown, the second measure was done post-lockdown. Right? So that's called repeated measures because same measure or same variable measured in two different moments in time. So this can be observational, like pre and post lockdown. This can also be in a context of an experimental research. Like for example, you want to see whether or not the knowledge of people in terms of, let's say, Philippine history in terms of martial law will be improved after their exposure to, let's say, an educational video. So you will measure their knowledge on martial law prior to the exposure to the video. You give the video after, and then you measure again their knowledge after their exposure to the video. So that is the example of an experiment. But for this example, it seems like it's observational. It's non-experimental. The lockdown happens in a natural setting, meaning the researchers have no control over the lockdown, but they do have the control of when to measure. So they measured prior to the lockdown and then after the lockdown. Now, when the dependent variable is continuous and then it's within groups, or what we call again the repeated measures. Now, if you have two observations, meaning two groups, kunyari pre versus post, and then it is seen in the same group, excuse me, then we use a paired t-test. So yung kanina, independent t-test. Independent because independent groups. This one, it's a paired t-test because it's matched groups. So if it's parametric, it's paired t-test. And if it did not meet the requisites of parametric tests, then we use a non-parametric statistic, and the non-parametric version of paired t-test is Wilcoxon sign test. Now, if you have three or more observations, like for example, pre, during, post. Or for example, after a person gets stroke, you want to measure the quality of life of that person per year. So, year 0, meaning the year that that person got stroke, and then you follow that person year 1, year 2, year 3. So you have more than 2 measurements, no? More than 2 repeated measures within the same group. Then we use a repeated measures ANOVA. So yung kanina, that's one-way ANOVA, and then ngayon, it's a repeated measures ANOVA. So it's easy to understand because you're using a repeated measures, no? And then for non-parametric version of repeated measures ANOVA, just in case you do not meet the requisites of normality, then you use a Friedman test. So yun siya. Okay, so let's summarize it using this table. So for the different tests of difference, we use these tests when the IV is categorical and the dependent variable is continuous. So if the difference you're testing is between groups, when there are 2 groups and you have sufficed the requirements of parametric tests such as normality, you use an independent t-test. If it did not meet parametric requirements, you use Mann Whitney. If the number of groups in your IV is 3 categories, then if you meet the parametric requirements, you use one-way ANOVA. If you don't meet the if you don't meet the parametric requirements, you use Krukall Wallis. Now, if it's again within groups or repeated measures, if there are 2 observations like pre and post, then you use a paired t-test. If it's parametric, if it's non-parametric, you use a Wilcoxon sign test. If it's 3 or more observation like year 1, year 2, year 3, etc., then you use a repeated measures ANOVA for parametric and then a Friedman test for non-parametric. Now, you will also might be, when you read articles, you will be reading more complex statistics. So I'll just give you we will not be doing it in class, but I will just give you like ideas of, what are the other more complex ways. Like for example, if you have an independent variable that's categorical and a dependent variable that's continuous, and then you have sort of a second factor that you want to see whether or not it will influence the relationship between the IV and the DV, then you might be seeing, like for example, a two-way ANOVA. A two-way ANOVA is the first way is the IV, and then the second way may be another independent variable or another covariate that you want to see in order to control for that covariate. Like for example of a two-way ANOVA would be, let's say, the independent variable would be, let's say, income. So that's low, medium, high. And then your dependent variable is, let's say, life satisfaction. But you also want to see whether or not there is an interaction between gender, male and female, and the income, because intersectionality, the experience of a person who's low income may be different if that person is a female or that person is a male. So the second factor, you can put it in a two-way ANOVA, but again, we will not be doing it in this class, but that's an example. Now, what if your dependent variable is also categorical? So, syempre, dahil hindi na siya continuous, hindi na magagamit, you will not be able to use all of this that I have listed. So, if the dependent variable is categorical, and you want to see associations between a categorical independent variable and a categorical dependent variable, we use a chi-square. The good thing about chi-square is that in itself, it's a non-parametric test. So, whether or not you have achieved normality, it's okay because you use a chi-square. The only problem with chi-square is that if you have more than 3 categories for either the independent or the dependent variable, it's really hard to imagine the direction of that association, whether or not if higher yung isa is lower yung isa. It's really useful only if you have dichotomous IVs and dichotomous DVs, But again, since chi-square is usually, we see the 2x2 tables, we see this usually in medicine, because usually when we talk about outcome variables in health, usually it's you get sick, you don't get sick, no? You have COVID, no COVID. And then usually we treat exposures as exposure, no exposure. So that's a 2x2 table. That's usually how we use chi-square. But in behavioral sciences, in the social sciences, you usually work with dependent variables that are continuous in nature, no? But I'm just presenting to you the possibility of chi-square kasi baka in the future you will need to work with outcomes that are dependent in nature, that are dependent variables that are categorical in nature, I mean. And then there's also what we call an ANOVA, no? So analysis of covariance, no? So for example, the two-way ANOVA I gave you is that the independent variable is categorical and the second factor is also categorical. So the first is income, low, medium, high, and then the second factor is, let's say, what's that, a male, female, gender. What if your second factor is not a categorical variable but a continuous variable? Like for example, you want to see the interaction of low, middle, and high income and age, because age is a continuous variable on life satisfaction, for instance. Now, if the first factor is categorical with multiple categories, obviously, and then your covariate is a continuous variable such as age, and you want to see the interaction of that on the dependent variable, which is, let's say, life satisfaction, then we use an ANOVA. But again, we will not be discussing that in our class, no, or I will not be asking you to do that in class. I'm just giving you, because in the future you might read published research and you might be encountering these things. And then you might also encounter what we call a MANOVA. A MANOVA naman is multiple analysis of variance. So the dependent variable, you have more than one dependent variables, no? So that's a MANOVA. But again, we will not use that in this class. So pagka dalawa or mas marami yung dependent variables, we use MANOVA. But usually in our classes, no, we only work with one. We only are interested in one outcome variable. Also, when you reach the levels of two-way ANOVA, ANCOVA, MANOVA, they're no longer bivariate statistics. They're already multivariate. Because again, bivariate, you're working with variables two at a time. So if you have now, if in one test you are working with three or more variables, na multivariate na siya. No? We will get to multivariate later, especially in regression. No? But the other types of multivariate statistics like, between subjects, repeated measures, ANOVA, ANCOVA, MANOVA, two-way ANOVA, hindi na yon, no? Because that's a very intricate, complex na siya. No? So we'll work, ang multivariate lang natin for our class will be regression. So those are the different tests for difference, and then after this PowerPoint presentation, I'll be demonstrating to you how to do independent t-test, Mann Whitney U test, one-way ANOVA, Krukall Wallis, paired t-test, Wilcoxon sign test, repeated measures ANOVA, and Friedman test in Jamovi. Hello everyone. So I think we're starting. Okay, so now I'm going to demonstrate to you how we can do the different tests for difference. So first, let's look at this in the context of the research that we are doing. So I'm going to use again the research study that we are working on in the context of practice, right? So yung practice natin na data. So let's just specifically look at question number 4, because question number 4 is an inferential question and basically asks the relationship between social demographic characteristics and national resilience. So if you remember our discussion earlier that usually we do tests for difference when there is when your independent variable is a categorical variable and your dependent variable is a categorical variable. Because when you look at 5, national resilience and life satisfaction are both continuous variables. So iba yung gagamitin natin for number 5, and that is what we're going to be discussing in next week, no? And then even actually within social demographic characteristics, meron din kayo makikita mga continuous variables. For example, in this sample case that we have, diba? you have aging years, no? And aging years in this context is actually continuous variable, diba? So we will not use t-test or ANOVA here and the other variants because this is not going to be a test for difference, rather a test for correlation, which again will be our discussion next week, no? But for the meantime, ito, so we will not be considering this, no? So remember na in our class, no, we are using a complex hypothesis. When you say complex hypothesis, yung isang tanong o yung isang hypothesis actually deals with a lot of bivariate tests, right? Why do I say do you have a lot of bivariate tests? For example, social demographic characteristics have multiple characteristics. So you have age, sex, region, highest educational attainment, and income. And this is going to be the same for your for the data that you're working on. No, more than one talaga siya. So in this case, since we have 5 social demographic characteristics and then we have national resilience, which also is a lot, tatlo siya. No? National resilience has 3 domains, which is identification with my country, social solidarity and social justice, and trust in public institutions. Kayo din, you have a lot then. No? You have more than one domain for the main variable that you have for your study. So maraming bivariate tests kayong gagawin, no, in class, no. But for the meantime, we're going to look at bivariate tests that test for difference across certain categories, and then we have to look at categorical variables. So we have to identify first yung nature ng variable. So for example, sex assigned at birth, meron tayong dalawang inassign na category sa kanila, and that's male and female. So that's dichotomous. So we have 2 choices. If it's dichotomous, independent groups, diba? It's either independent samples t-test kung ito ay parametric, and then Mann Whitney U kung non-parametric. That's also the same for the region. Kasi dito, region is NCR and non-NCR. So dalawang groups lang siya, dalawang categories. So we are going to use yun din, independent t-test or Mann Whitney. So it's also very important in terms of the way you categorize or you measure the variables. Kasi for example, kung yung region dito is ginawa nating 12 regions of the Philippines, it's not going to be applicable anymore for independent t-test because it's more than 2 groups. So it's really based on how some of them are, dichotomous because there's no choice, no, like male and female, there's no other way, no, usually in research. But for region, you have many ways of imagining it, no. But in this case, I'd like to operationalize region as NCR and non-NCR. And then we have highest educational attainment. We have 3 categories: high school and below, college, and postgrad. So, and then same for income classification, we have low, middle, high. And that's going to be your information in relation to what type of test for difference you're going to use in order to see the relationship between these specific variables with national resilience. And that is ANOVA, no, one-way ANOVA for parametric, and then Krukall Wallis for non-parametric. And then we don't have it in this specific scale. I'm sorry, we don't have it in this specific tawag dito. We don't have it in this specific example, but we will do later in a different data set yung repeated measures, no? So let's start. So let's work first on the question: is there a significant difference in the national resilience for the 3 domains when grouped according to sex assigned at birth? So you go to analysis, and then you click on t-tests, and you click on independent samples t-test. Now, you have to put the dependent variable, which is the outcome variable. Makikita nyo naman dito, no? In that box. So let's start with identification with my country, and then you're going to put the grouping variable in this window, no? And then lalabas na yung statistic, no? So as you can see, dapat the first thing that you have to look at is the p-value. If the p-value is less than 0.05, then we reject the null hypothesis. So dito nakita natin that the p-value is more than 0.05, then we don't reject the null hypothesis. So what do we say? There is no significant difference in, at least in the independent samples t-test, ha, kasi mamaya pwedeng magbago yan. So let's now check if that's going to be the same with solidarity and social justice and then trust in public institutions. So let's put that here. So pwedeng sabay-sabay siyang ilagay. So you now have 3. You have the T statistics here. Ito yung T statistics. So what you have to do here is just report it. I'll teach you about reporting by varied tests next week. No? But here you have to look at the p-value. So dito yung unang tinitignan natin, no? The p-value. Makita nyo siya and it appears that it's more than 0.05. So we cannot reject the hypothesis and therefore we cannot there's no significant difference. No, we can actually further get and then how do you get the mean and SD per group? So you click descriptives. So here you'll be able to see the mean and SD for 0 and 1. 0 yung females, 1 yung males. So makikita natin sa 0, yung mean is, almost the same as the females, no? Same with the SDs, no? So you can really tell na there is. You can actually even visualize it, no? Using descriptive plots. So makita ninyo yung pagkakaiba ng lalaki at saka sa babae. But it appears that there's no significant difference here. However, dito ay ina-assume natin na parametric siya. Remember that we have to ensure first kung parametric ba to o hindi. Now, you can actually check immediately here yung normal distribution. No? So let's click normality test. So, makita niyo yung Shapiro-Wilk test for the 3 values. No? Shapiro-Wilk for identification with my country, for solidarity and social justice and trust in public institution, lahat sila 0.001, yung Shapiro-Wilk. So, we cannot assume parametric. No, hindi siya normal. So, we cannot use a parametric test. So, what we will use is a non-parametric test. So, ito, nakalagay yan, student t-test, yun ang automatic. But you can actually change this to a non-parametric version and that is Mann Whitney U. So makita nyo nagbago na yung statistic niya, naging Mann Whitney U niya, no? And then when you look at the p-value, the identification with my country, nagkaroon na ng significant difference. Para natin nasabi because the p-value is now less than 0.05, no? Nakita nyo yung p-value niya dito is 0.024. So ibig sabihin there is a significant difference, at least using a non-parametric test, no, you are already able to see a significant difference between males and females. So sino ang mas mataas? So that's the time you look at the group descriptives here, no. So as you can see, the males, no, yung 1 have a higher mean. So ibig sabihin males have a higher score for identification with my country compared to female respondents. No? And then in research, you will have to explain bakit kaya may significant difference. And then comparable ang scores nila in relation to solidarity and trust in public institutions. Okay? So yun siya. So that's how you do an independent samples t-test. So now let's do that for palitan na natin tong sex, no? And then let's do the second dichotomous variable here, which is region. So I'll put region here. Ayan. So as you can see, and again, no, check natin ulit kung if we can use a student t-test. We can't because the Shapiro-Wilk remains to be 001, 001. So it's less than 0.05. So ibig sabihin there is a violation in normality. So we still keep using Mann Whitney U. So we look now at the p-value here. So the p-value shows that for the identification with my country and trust public institution, it's less than 0.05. For solidarity, it's higher than 0.05, so no significant difference. So may significant difference tayo kay identification with my country at saka trust in public institution. Now we can look at the descriptive statistics to tell us sino ang mas mataas. Is it the NCR people or the non-NCR people? So the 0 are the non-NCR people, the 1 are the NCR people. So as you can see, the non-NCR people have a higher score in terms of identification with my country and trust in public institutions. So yung mga nakatira outside NCR, they seem to have higher levels of national resilience in terms of identification with country and trust in public institutions. Okay? And then for solidarity, the values are comparable. And as you can see here naman talaga sa mean niya, parang sobrang minute lang yung difference niya compared doon sa identification with country at saka trust in public institutions. So that's how you do your independent samples t-test and Mann Whitney U. So as you can see, simple lang siya in terms of just clicking here. So what are the values that are important for you to see? No, it's the p-value, no, because that will decide whether or not you have to reject or not reject the hypothesis. And then after you've seen that, you have to report on the mean. As you have to look at the mean and see which is higher, no, so that you have an idea kung sino ba yung mas mataas kung may significant difference. There's no need, hindi man sa no need, no, pero you can check if there's no significant difference, you can check the mean and SD to really confirm na ay wala talaga silang pagkakaiba or sobrang lapit ng score nila. So you can also click here the effect size, no, which is the D, no, and then as you can see, no, makikita nyo na rito yung effect size, no. Ang effect size usually it's very important for students t-test kasi the Cohen's D yung ginagamit. So as you can see here, parang nasa around low to moderate yung lumalabas na effect size, no. But for Mann Whitney U, usually we don't really compare, no, sa rank by Syria. We don't really have to report it anymore, no. Pero just in case you wanna see, andito siya, no. Ayun. So that is for your dichotomous variables. So let's move to your categorical variables with three or more groups. So we have highest educational attainment, income class, classification, no? So let's go there, no? ANOVA, click ANOVA and then one-way ANOVA. Ayan. And then you you identify the grouping variables. For example, let's look at educational attainment. Let's put educational attainment here in the grouping variable. And then we can already also include all of the continuous variables. Okay, and then look at the p-value and identify whether or not there is a significant difference across them. So as you can see, the p-values are higher than 0.05. So therefore, we do not reject the null hypothesis. There is no significant difference in the three domains of national resilience when grouped according to educational attainment. Again, we can visualize that by adding your descriptive table. So nakalagay na dyan yung mga means, no? You can actually also put descriptive plots para makita nyo kung pagkakaiba. So as you can see, may mga overlaps, no? So hindi talaga sila magkakaiba, no? So let's move na lang sa isa na mas interesting, which is income. So we have low, medium, high income. So as you can see, no, for the three, the p-value is less than 0.05. No? So if it's less than 0.05, then we reject the null hypothesis and infer that there is a significant. All right. So now that we know that there is a significant difference, let's now do a post-hoc analysis. So ang question yan, okay, so may pagkakaiba. Pero remember, tatlong grupo yan. Low, low, middle, and high income. So alin dun sa low, medium, middle, and high income ang actual na magkakaiba-iba. So we now will click post-hoc test. So we choose two key tests, no? And now you will see here a cross tabulation of 1 versus 2, 1 versus 3, 2 versus 3. So you will see here that the mean difference of low minus the value of those in the middle class is positive and the p-value is 0.01. So it means that there's a significant difference between 1 and 2, with 1 having higher levels of identification with country. Same thing with high income. So low income versus 3, which is high income. Look at the p-value, it's also less than 0.05. So ibig sabihin, there's a significant difference between 1 and 3 with lower income people having higher levels of identification. So it appears that yung mga mas mahirap, sila yung mas mataas ang identification with the country compared sa mga mas mayaman. And then when you look at the middle versus high income, the p-value is 0.513. So it means that there is a hindi significant ang difference between middle and high income. So it's really just the low income having significantly higher scores of identification with my country pagdating sa identification with my country compared to their middle and high income counterparts. So let's look at the other. So same thing, no? Mas mataas ang solidarity scores for low income versus middle and low income versus high as indicated by the p-value that's less than 0.05 here. And same thing, yung 2 and 3, hindi din sila nagkakaiba because the p-value is higher than 0.05. So it means that significantly higher ang low income compared sa kanilang middle at high income counterparts in terms of solidarity. Let's look at trust in public institutions. So it appears that low income individuals have same thing, yung p-value for for low versus middle and low versus high, pareho pong p-value is less than 0.05. So there's a significant difference, and specifically significantly higher yung low income. And then at the same time, middle and high income, it's comparable, no? Kasi the p-value is more than 0.05, and therefore we do not accept that they are significantly different. So again, same thing, it's the low income who report higher solidarity, higher trust in public institutions, and higher identification with the country. No? So again, in research, we'll have to explain and make possible discussion and interpret why do you think this would be the case. No? But again, we're doing this in the context of tawag dito. We're doing this in the context of we are assuming that this is parametric, no? But again, you really have to test first whether or not it is parametric or not. So, how do we test if it's not if we can do parametric? Then meron din ditong option for normality test. So, let's click normality test. And as you can see, same thing, no? Shapiro-Wilk is significant for the 3. So, we apparently should not have done an ANOVA. So, I just did it para lang makita nyo how a one-way ANOVA would look like. But based on our Shapiro-Wilk results, we cannot do a one-way ANOVA. So we have to do a non-parametric version of ANOVA, which is Krukall Wallis. So where do we find it? So click ANOVA, click one-way ANOVA, Krukall Wallis. No? So the bad thing, the not so happy thing about non-parametric, it's not as insightful in terms of findings compared to parametric. As you can see, the other analytical tools you have here aren't as robust as parametric. No, but since that's what the data is, that's the behavior of the data, that's the distribution of the data, there's really not much we can do about it. No, so sige, so let's move now to let's do the same, no? So we put the 3 dependent variables here that are continuous, and then we put the other, and when we put income class here, ayan. So but same thing, the p-value is less than 0.05, but as you can see, the statistic that is reported here is x squared na, hindi na siya f. So if you can see here, no, f yung nire-report niya, dito ito yung f. No? So nire-report nyo yan. But what you really use to interpret is the p-value. No? And then you can do pairwise comparisons to see whether or not there's a significant difference between or across the variables. For example, low versus middle, significant. Low versus high, significant. Middle versus high, not significant. So same thing here, low versus middle, high. Low versus high, significant. Middle versus high, not significant. So same thing with trust in public institution. Low, middle, low, high is significant. Middle, high is not significant. The W is the statistic, but where do you find which is higher or lower? You have to go back doon sa mean distribution. So again, ganun pa rin, no? 1 is higher than 2 and 3, obviously, here in our findings. So it's interesting, no? It is the poorer populations, no, the poorer Gen X and Gen Y who have better identification, better solidarity, and better trust in public institution compared to their middle and higher counterparts. So there are many speculations in relation to that, no, but that won't be a part of my discussion, no. Maybe we can talk about it in class later. But yeah, so that's how you do a non-parametric, no, a Krukall Wallis test. Now, what if we want to use naman a repeated measure? So, ibig sabihin within analysis. So, for example, we want to see whether or not quality of life within this group of 700 participants has improved, no, or it has changed pre and post pandemic, no. So, you have here same measure, all quality of life. Ang pinag-iba lang ay when it was measured. So ang tawag dito ay repeated measure. So quality of life was measured multiple times in different periods, no? So if, for example, the question is there significant difference in the pre-quality of life and post-quality of life scores in the sample, then we will use a paired t-test because dalawang observation lang siya. So let's do paired t-test here, no? So again, click t-test and then paired t-test. And then you will just have to include here the paired variable. So I would put here, so hanapin natin yon. So for example, pre and post lang ang gusto natin. So pre and post, so I put here. So you see here, there is a t-statistic, there's a p-value, and it's less than 0.01. So it appears that there is a significant difference in the quality of life pre-lockdown and post-lockdown. Okay, so if you want to be able to see which is higher or which is lower, you can click the descriptive. So makita natin that the mean for the pre-lockdown is higher than the post-lockdown, no? Which makes sense, no? And then you can actually include the effect size. So the Cohen's d is moderate, no, 0.46. No, they have a moderate effect size. But again, let's check first the normality test. So now meet ba yung normality test? So when you look at Shapiro-Wilk, no, it's higher, it's lesser than 0.05. So Shapiro-Wilk is significant, therefore we cannot assume normality. So we have to do a non-parametric test. So what would be the non-parametric test? Wilcoxon rank sign test. So dito yung Wilcoxon sign test. Click ito. So iba na ngayon siya, you would see. But you would see here that it's the same, no? You see that the p-value is still 0.001. Okay? So ibig sabihin there's a significant decrease, no? There's a significant decrease in quality of life post-lockdown compared to pre-lockdown. So that's paired test. No? So as you can see, we are measuring the same sample, diba? But the measurements are the same but in different times. So the dependent variable here, the independent variable here, if you will, no, is the time of measurement, no? But the measures are the same. Kanina, if you notice sa independent samples, single period of collection, but we are differentiating across groups within the sample. So that's the difference. Kaya sa paired sample kasi paired or repeated yung measures, no? But we use Wilcoxon here or the non-parametric kasi nga we did not meet the parametric assumption. So what if more than two? For example, we want to see the difference from pre-lockdown, year 1 of lockdown, year 2 of lockdown, and post-lockdown. So let's see. So let's move to ANOVA and then let's click repeated measures ANOVA, assuming that this is parametric. So may mga tawag dito things that you have to do, no? So first is you have to identify the factor. So quality of life is the factor, and then you have to identify whether there are levels. So the levels are you have the pre-lockdown. I have the year 1, you have the year 2, and then you have to add the 4th, which is the post. Okay? And then you have to identify dito sa repeated measure cells kung ano-ano yon. So I'm putting pre here, year 1, year 2, and post. So may lalabas na ng mga variable na findings dyan. Let's just wait. Medyo mabagal lang. Okay. Sige. Ayan na, lumabas na siya. So, as you can see, the p-value is less than 0.001. So, ibig sabihin there is a change across time. So, how do we ascertain which the changes? So, first, we can visualize it. So, wala pala ditong visualization. No? We can do post hoc tests. So, let's do post hoc tests. Okay. Mabagal lang siya. Let's wait for it. So, ayan. So for the post hoc test, you would see here that the pre versus year 1, the p-value is less than 0.05. So may pagbabago sa year 1. And the mean difference is 1. So ibig sabihin, higher yung pre ng year 1, yung pre than year 1, no? Higher yung pre than year 2 at higher din ang pre than post, no? So sa year 1 naman, than year 2, mas mababa si year 2 than year 1 than year 2 as seen in the negative score here. So ibig sabihin, mas maliit ito, mas mataas ang year 2. So in 2020, no, mas mababa yung quality of life at tumaas siya nung year 2. At mas mataas pa rin yung 2020 kaysa sa 2022. Mas mataas yan. Mas mababa si year 1 kasi nga the negative. And then year 2 to post, negative siya. So ibig sabihin, mas mataas si post than year 2. And then as you can see, the p-values, it's all less than 0.05. So it means na across the board, no, across the board may changes. So pre, it was high, bumaba siya, year 2 low, and then may significant increase in year 2, and then may significant increase in post-lockdown. So pre-high, dip year 2, dip ka ng 2020, increase ka ng 2021, and then increase ka ulit ng 2022. Okay, so that was the movement, no? And all of the changes are significant according to the p-values. Kaso, again, let's do the assumption checks, no? Wala ditong normality, but we will take this normality tests, no? Sige, let's do the exploration and let's do the normality tests kasi wala doon, no? So Shapiro-Wilk, ipasok natin yung 4. So as you can see, Shapiro-Wilk, all high, all significant, I mean, so all less than 0.05. So we cannot use the repeated measures ANOVA. So we will use now a repeated measures ANOVA that is parametric, and that's Friedman. So let's do this. So ilagay lang natin yung 4. So where are those? Ayan. Ayan. So makita nyo, it's less than 0.001. So nakita nyo, hindi siya masyadong insightful, no? Pero there is a significant difference across, there are longitudinal associations, no? Across time and quality of life from first year, second year of lockdown and post-lockdown. We can also reproduce descriptives, no? So as you can see, tama nga yung assumption natin, no? As you can see, the mean pre is high during pre, got low in first year, got higher a bit in year 2, and then post got higher. Pero mas pataas pa rin yung pre. So ibig sabihin, hindi nabawi yung quality of life post-lockdown. Can actually do a descriptive plot. Ayan. Actually, parang mas maganda pa itong non-parametric kasi meron siyang plot. So makikita mo talaga dito in the descriptive plot, no, kung ano yung movement niya. So mula dito sa mataas, nag-dip nung year 1 and then incrementally umakyat year 1. And but as you can see, from hindi naabot yung pre-pandemic or pre-lockdown quality of life, no? Mas mababa pa rin siya. So that is how you use a repeated measures ANOVA. But since you weren't able to use So this is just a demonstration, no, for the paired t-test, Wilcoxon, repeated measures ANOVA, and also Friedman. So Friedman to, no, itong ginawa natin ito. We were not able to, you will not be able to do it on your own, no, kasi wala naman kayong kinolect na repeated measures na data, no? So you will not be doing this, but I demonstrated this to you para meron kayong idea just in case you need it for future. For example, especially sa mga international studies majors dito, for example, you wanna be able to see the changes, let's say in let's say GDP rates, no, in a specific country for year 1 to year 20. No, so this repeated measures ANOVA would be a good way to ascertain, no, if there is a significant difference in GDP across countries from year 1 to whatever year you want to end, no? So that's another example of the use of repeated measures ANOVA in another social context. Okay, so there. So that is our Jamovi demonstration for the different tests for difference.